everyone, welcome back to my channel EduVibe. In today's lesson, we are start with the one shot of the all units of the grade 12 physics. As you all know that on 22nd June, you have your diploma for physics, and so we do one shot for all the units, which are the 4 units in 4 days. Today we are main focus on the momentum and impulse, which is unit A. So we revise all things and we do some questions at the end. So we start the chapter with the momentum and impulse. So the topic is that. So the momentum of an object is the tendency to want to continue moving forward. It is a vector quantity and we can define it by the P is equal to m times v. M is your velocity and m is your mass and v is your velocity, or you can say the speed. So this is the vector quantity. So that's why they include the direction too. So the change in momentum is the impulse. When you have a change in momentum, which is called the delta P, called the impulse in that case. So the equation is not directly on the data sheet, so we have to memorize this thing, and all the things are equal to each other. Each side of the above equation is equal to the impulse. So you can write it like this is equal to the net force times delta T, and this is equal to m times delta V. So if you have net force and time, so you can use the delta P you calculate the change in momentum in this, which is the impulse. So that's all the momentum and impulse we discuss when we do in this unit. So be careful with changing the direction, as a common to ask question on diploma where a change in direction has been occurred. So we must be careful with signs. So if it's something is goes left and then it goes right, so you can take left as positive, left as negative, and right as positive. So that directions can be matter. The north, south, east, west can also be matter in this. So the directions are very important, and there is a common question in diploma. So when two objects interact, which means collide, the impulse they experience will be the same but in opposite direction as the co-sequence of the Newton's third law. So if there's an equal action and reaction, which is the third Newton's law, and we do in the collision and the rebound thing in this chapter. So then we have a force time graph, which is a very important graphs. So the equations for the impulse above are only valid for the constant force. If you have a constant force, so we can use the above equations like this one. But if we don't have the constant force, so we use the force time graph thing. So we can examine the area between the curve or the horizontal axis of a force time graph. So if you have to find the uh, impulse from this to means this, so you can find the area between them. The area between them give you the change in impulse again, which is the delta P. So you can use this thing. The area is the impulse. You may be asked to do something with this area. So determine the mass, then determine the initial or final velocity. After they ask you a question about this, as a follow-up questions. Like in first question, you have to find the impulse from the graph. Then you have to find the mass, velocity, anything. Then we do some theory-based questions, which are based on the safety and the impulse. And you can say the topic is called the maximum speed. You can check this thing. Done. So this is the maximum speed topic. If we compare the identical object that have the same initial and final speeds, they will experience the same impulse. And examine the equation is this. We already did this equation where the force times delta T. So if the identical objects have their same initial and final speeds, so the experience the impulse which is also the same in that case. To keep the impulse constant, we either have a large net force acting over a small time or a small net force acting over a large time. We have a large net force over a small time, which is very important. That if we have a large force, so we have over a small time. But if we have a small net force, so we have over a large time in that case. For safety applications, we prefer this method. So you have to be know about these questions. You get the one question in diploma for sure, including that maximum speed topic. Then we do the interactions in one dimension. Then we do the interactions in the 2 dimensions, which are little bit different. So assuming the system is isolated means we have to use the conservation of momentum and there is no external force acting on that. You may assume that the total momentum before an event happens, it is equal to the total momentum after the event happens. So the before momentum and the after momentum If it is equal, so you can say the system is isolated. And we can use this quotient in the classification in one dimension, two dimensions. So if in a one dimension, so you can use this thing that the total momentum is equal to the total momentum before and after. In two dimensions, we are considering the x and y components. So if the x component total momentum is equal to yx component total momentum after and before and after. Same with the y component. So in the one dimension, we can generally solve the questions and we get the, like, we only deal with the one dimensions. In the two dimension, we deal with the x and y components when the questions go long. We do the all the things in that. Like we have these type of things. We can say the three collisions and rebonds. The first one we consider is the hit and rebound collisions. So in this, the two objects undergo a collision, the two objects stand moving in opposite directions in the same direction, or one of the would be at rest and other object is moving towards it. So after this collision, the rebound has been happened. Not they do not stick together. The rebonding can be happen, which means that if the some project is here and it goes over there and some is here, those over there, they collide, but they go into their opposite directions again. They do not stick, they do not explode, they do that thing. So the formula we consider for this is Vm1 V1I plus M2 V2I. This is the initial thing, and for the final M1 V1F plus M2 V2F. So this formula we consider the initial thing and final thing both, because they didn't do anything. If there's something in rest, we get it as 0. But we can't cut anything from the equation. Sometimes you have to use all the things for this type of questions if they go to the opposite directions. Then we're doing the hit and stick thing, which is that thing when they collide. So two objects approach each other, and when they collide, they stick together when there is one object. They come object over there, one object over there, they stick like this. And they move into the one direction, not their opposite directions. When they stick, they move into the one direction. Direction is not matter, that which direction they go, they do into one direction. For this kind of thing, we consider the initial thing, because initial thing stays the same as the hit and rebound thing, which is m1 v1i plus m1 m2 v2i. But the final thing, the mass should be done add up, so that they become the one object, which means the mass is now together. So m1 plus m2, and the final thing is also equal. So v, the velocity is 1 2 for final is the same. We take it as one velocity. So this formula is for the hit and stick collisions. So you can use hit and stick collisions. Sometimes something is at rest again. So you can cut this out at 0 and you can solve the questions for this. So that's how the all this work happening for the hit and stick. Now the last thing we did in one dimension is explosions. What will happen that both objects are in the one object, they have rest, they are at rest. The object either be at rest or be at in motion prior to the explosion. So which means that when they explode, they cut into the pieces. The firstly, they always stays at rest like this, and when they like explode, they move to their respective directions and they have a different final velocities after that. So in that, the initial thing goes to 0. So we can't take the initial thing anymore. We only take the final thing for this torsion, for the explosions. So the m1 v1 of final plus m2 v2 of final is equal to 0. Initial is can't be taken. So that's the explosion. And explosion question we also did in the two dimensions too, where we deal with the two dimensions thing. We deal with the explosion thing too, where we x and y component can be considered in that case. So that's the one dimension, and we're also doing the two dimensions. So two dimensions are little bit difficult solving for the solving perspective. In this, we have 4 types of questions. We get the right angle equation questions sometimes, where we have a two-dimensional equations. We will look at for the both and x and y directions. We want to take x and y directions, and we find the magnitude and the angle. So that's a simple. Only we have a right angle equation. We have a right angle triangles like this. We use the hypotenuse theorem in this because this has a right angle triangle. In the non-dimensional vector resolution, we can use the simple right angle trigonometry required to solve the vector into its x and y components Remember to be in degree mode. At the end, we definitely find the angle and magnitude for the vector evolution, but the x and y components can be found first. The x and y component can be found by the method you have to use, that momentum thing, x component, and momentum at the y component. You have to deal with those, add up the things, make the vector diagram, then the angle, and then the magnitude. So direction is very important in all of these questions. So the like south of east, that type of questions you have to know in this. In the non-right angle questions, you will get the questions, but in the non-right angle triangle now, which means that you don't have like a straight end, like two objects. We have two objects, they collide, but they go like this. This is not a right angle triangle. This is a non-right angle triangle, and they are the questions of non-right angle triangle. So you have to deal with this question, same method, but you have to find the initial thing at x, then final thing at x, then find the x and y component. The one extra step can be added. The which thing you have to find there everything, that if you find a velocity, so you have to find the velocity at s component, velocity at y component, then separately you have to find the x and y components, then the magnitude, then the angle. So it's a long process going on. And also in explosion questions, explosion can be very like big questions, but you have to now again consider the which question says that in which direction explosion can be occur. After that, you have to find the x component, y component, resultant vector, and magnitude and the angle. Magnitude and the angle can be made in every question, which is very important for this type of questions. So two dimensions can be difficult, but you get the one question from this two. One question from the any of these four. So you have to know how to deal with those type of questions. Next thing we did is the classification. Interaction classification is 1 and 2 dimensions. In both dimensions, the classification stays the same. We can say the same thing in both things. So to determine the elasticity of the collision, we must examine the total kinetic energy of the system before and after. So for the kinetic energy, for the elasticity, elastic or inelastic, we have two types of elasticity. For this, we have to find the total kinetic energy before and after. If before and after energy is equal, so we have elastic collisions. If not, so we have inelastic collisions. If the total kinetic energy before and after collision is equal, the collision is the elastic. That's I told you. And before and after is not equal, so we have a inelastic thing. And one thing in this, that if we have a hit and stick collision in your question, and they ask that this collision is elastic or inelastic, you have to tell that it is always inelastic. So in the hit and stick collision, you always have an inelastic collision, not in rebound, only in hit and stick. So this is a common diploma question that they asked, they give you a situation that this is a hit and stick collision, this is a situation of that, and tell me that this is the last turn inelastic. So I have to tell directly that this is inelastic. You can't have to find anything. You just say that this is the inelastic collision. The elasticity is dependent of the nature of the system. Is isolated or non-isolated. So now isolated and non-isolated thing is dependent. So elastic, if we find the momentum, if the before momentum and after momentum is equal, so we have a isolated system. If they are not equal, so we have a non-isolated system. For the isolated and non-isolated, you consider the momentums. For the kinetic energy, you consider the energies, the kinetic energy. So that's all you have to do, and this is a very easy question to get 1 question for sure. Like this is a kinetic energy formula. You all know that EK is equal to half mv square. Make sure the units should be same. The kinetic energy should be in joules, mass should be in kgs, and speed should be in meter per second. And this is a scalar quantity, and direction is irrelevant. We can't take direction in this. This is the scalar quantity. Then the last few copies we consider the conservation of energy, which is EKA plus EPA is equal to EKB plus EPB. There are questions we involve for the combining conservation laws. We do the ballistic pendulum, which is that thing which then do the rotation thing. That if we have some project over there and there's something like hit over there, so this bounces over there and it goes over like this. Sometimes the bullet question you get, that bullet is stuck into this because bullet pushes over there and they stuck over there. So what is the height of this? What's the velocity? That type of question you get from this. So that is called the ballistic pendulum, and we have a projectile motion in this. We get to say the projectile things. So that's all question you have to consider in this. That is all the swing to the other to some maximum height. They swing because there's a bullet at the high speed, and when they hit the block, it goes upwards like this. This is the last topic you get. I think you get the one short question on this. So you have to know that which is this type. So you have to know the meaning of this. You have to know how to deal with those type of questions and all the things. So that's all the unit of quantum and impulse. So now we're doing some practice questions of like each type in this questions which are very important in the diploma point of view. So first question says the 1500 kg car is traveling at 80.0 km per hour west along the white mud. Determine the momentum in kg per meter per second of the car. So you have a mass is given, and this is traveling that space, so we have a velocity. But the velocity is in kilometer per hour. We have to convert it to meter per second because we want momentum in kg per meter per second. So for 80.0 kilometer per hour, to convert this in, so 80.0, we have to multiply this in 5 by 80, which is, you know, that 1000 divided by 3600. When you combine this, you get 22.22 meter per second. Now you can use this thing over there. So this is 1500 kgs, 22.22 meter per second. And when you calculate this, you get about 3.33 into 10 raised to power 4 kg dot meter per second. So it goes west. So if you take the west as the negative thing, so it stays the negative, it stays the, you take a positive thing in west. So you get the positive and you say this is the west. Because this is a momentum is a vector quantity, so you have to state the direction, which is very important. Next question we have. The question says, a small 705 kg tire accelerated from rest to speed of 27.9 meter per second by a force of 1.20 kilonewton. Determine the magnitude of the change in momentum. We have to find the impulse produced by the project and iteration time force acting on the car. So basically find the delta P, and we have the force which is called the net force, and we have a speed over there, and we have a mass too. So we can use something that. So we have a mass. So for the A part, for delta P, we can use the mass times delta V. We can use this. So delta P mass times final minus initial. So this is the final minus initial. This is that rest. So the initial thing goes to 0. So we have 27 minus 9, which is 27.9. So mass is 705 kgs. Multiply this by 27.9 meter per second. So when you calculate this, you get about 1.97 10 raised to power 4 kg dot meter per second. And for the B part, you have to find the attraction time. Now, you know the another formula for impulse, that this is equal to the net force times the delta T. You can isolate the delta T, which is change in momentum upon net force. You calculate this, so 1.97, yeah. So momentum is 1.97. Make sure you use the non-rounded value when you calculate in this. 4 kg dot meter per second. Divide this by the net force. So net force is 1.20 kilonewtons. This is basically the 1.20 10 raised to power 1000, which you get about 1200 newtons. You have to use the newtons. So 1200 newtons. When you calculate this, you get delta T of about 16.4 seconds in 3 seconds. This is delta T. This is your change in momentum. This is the impulse. So that's our question. You get the both formulas are covered in that question, and maybe you get this sub question. So you have to be careful in these type of questions, that how can we deal with that question actually. Next question we have. So question says a 2300 kg truss slams on his brakes on an icy winter day in Edmonton, but continues to slide at a speed of 3.50 meter per second into a 1700 kg stationary car at red light. Upon collision, the car forward into the direction at the speed of 2.50 meter per second. The truck does not stick to the car and moves independent of the car after the collision. So determine the speed of the truck after the collision using the law of conservation of momentum and show that the collision was elastic. So in one question they cover the two topics. They cover a topic called the hit and rebound and they cover the topic the classification in one dimension. So the first thing we have to find the speed of the truck, which is like after the collision. So we have to find the V1F because for the first truck I think, yeah, for the truck and second one is the car. Okay, so you know what's the formula. So M1V1I, this is the hit and rebound thing, plus M2V2I is equal to M1V1F plus M2V2F. So I take first thing as a truck and second thing as a car. They mentioned that car is initially at rest, so that this thing goes out. Now you isolate the V1F. You have to find the V1F in first, because for the truck we have to find after the collision. So you can isolate this, you get M1V1I minus M2V2F. Divide this by the M1. Now you can just put the things in. So 2300 kgs, V1I 3.50 meter per second minus 1700 kg times it by 2.50 meter per second. The M1 is 2300 kgs. So when you find this thing, you get about 1.65 in 3 digits meter per second. This is the V1F for the first part. For second part, you have to show that this is the elastic. For elastic, you have to compare that the kinetic energy initially and the final. If they are equal, if they are not equal, so then this is elastic. So for the B part, first define for the initial. So kinetic energy at initial is equal to kinetic energy of 1 at initial plus kinetic energy of 2 at initial. So half M1V1I plus half M2V2I. So the half, this is 2300 kgs, then 3.50 meter per second square. This goes out because M2, which is the mass of the car, is at rest at initially. So to just find this, so you get EKI of about 14087.5 joules. Now you have to find the EKF. For EKF, the half M1V1F squared plus half M2V2F squared. Done. Now you have to plug it in. Now all the things can be used. So this is 2300 kgs and we have 1.65. We already find this now in the first part. Meter per second squared plus half. This is 1700 kg and we have a 2.50 meter per second square of this. When you find this, you will get about, what do you get? Okay, wait. You will get 8451.6 joules. So in this, the EKI is not equal to EKF. Hence, this is the inelastic collision. And we proved that. That's all we have to cover in the mastermind impulse one shot. So this is all the things, and if you want the separate lessons, so you can check the description and you can go to the full playlist of this chapter. This is a very important chapter, easy chapter as compared to all three, so you can deal with those. So I hope you learned something new in this. So learn me where to vibe, learn smart not harder. Please like, share and subscribe to my channel. If you have any questions, let me know in the comment section, and all the best for your diploma. So see you in the next lesson. Till let's get it with EduVibe.